This is lab for section 5.8, and this is going to be taking a look at endothermic and exothermic reactions. So we'll get to the definitions of these in a little bit and connect this to lecture as well. We have 4 miniature experiments, and they each just take a couple minutes each, and then we'll have a discussion about everything as well. In the first experiment, what we have is we have acetic acid. Another name for acetic acid is going to be some vinegar. And we also have sodium bicarbonate, and another name for sodium bicarbonate is just baking soda. We don't need to know about the chemical reaction. We're just trying to see, is this reaction going to be releasing heat, or is it going to be taking heat in? And so we'll take a look at the temperature, and we're going to see what happens there. Our second experiment, we're going to be taking hydrochloric acid, which is this compound here, and I have a piece of metal. It's actually magnesium metal that we're going to be dropping into this. And is this going to release heat, or is it going to require heat to come in? The third reaction that we're going to be looking at is going to be dealing with this substance called ammonium chloride, and we're just going to dissolve it in water, and we're going to see what happens to the temperature. In the last experiment, we're also going to be taking water. We're going to be dissolving a substance called calcium chloride. So we're going to be seeing, is heat going to be released from this, or is heat going to be required and heat getting sucked into the reaction? So our first reaction, we are going to be looking at, again, the vinegar and the baking soda. So I have 4 thermometers here, and we're going to be assuming that all the thermometers are going to be the same temperature, and all these thermometers are reading about 22 degrees Celsius. So we're going to assume that they all are at 22 degrees Celsius as the starting temperature. And I'm going to be taking the baking soda and putting this in, and we'll see what happens here. And I'm going to put the thermometer in and enable for you guys to see what happens to the temperature here. You can see the temperature has actually dropped. Okay, so the temperature has gone down to about 17 degrees Celsius. So for our first experiment, it went down. So the initial temperature of the acetic acid or the vinegar was 22 degrees Celsius. The temperature after adding the baking soda, it dropped down to 17 degrees Celsius. There actually was a temperature drop. I could feel a temperature change in my hand. It felt cooler. Did you observe, what did you observe during the reaction? There were lots of bubbles. So did you feel a temperature change? Yes, and the experience was cooler. What did you observe during the reaction? Bubbles formed. So it's as simple as that. So we're going to be going on to our second reaction, again starting off at 22 degrees Celsius, and we're going to be dropping in this magnesium, which is very similar to the zinc metal. Okay, so we'll see what happens here. Okay, we can see what's happening to the temperature. It's going up quite rapidly. And of course, I could feel this. This is 37 degrees is body temperature in terms of Celsius. And this went up to about 40. Yep, went up to about 40 degrees Celsius. So I definitely felt the temperature change there as well. So we started off at 22 degrees Celsius, and after adding the metal, it went up to 40 degrees Celsius. Did you feel a temperature change? Yes, it became warmer. What did you observe during the reaction? Well, bubbles formed, and also the metal dissolved. So just bubbles forming doesn't mean the temperature is going to get cooler. Bubbles forming doesn't necessarily mean that it's going to get warmer. It's just showing that the chemical reaction is taking place, and there's 2 different chemical reactions, and in both of those cases, bubbles were formed in both of them. Okay, now the third one is going to be taking a look at what's called ammonium chloride. Okay, so again, we're starting off at room temperature. I'm going to pour my ammonium chloride in, and I'm going to stir, 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 and try to dissolve this stuff. Okay, this one is very cold. It's even colder than the baking soda. I can feel it significantly colder. And hopefully you guys can see the temperature as well. This is dropping down to now 14 degrees Celsius. It looks like it all dissolved as well. So initial temperature was room temperature at 22 degrees Celsius. Temperature after was 14 degrees Celsius. Yes, again, this one got cooler. What did you observe during the reaction? The ammonium chloride, or the white solid, the solid simply dissolved. There was no chemical reaction in this. The only thing that was happening is we were dissolving something like salt in water. That's what this reaction was showing. So sometimes to dissolve things, it requires heat to do so, and it pulls the heat in. Last one is going to be, here's just regular water, and here's calcium chloride. I'm going to dump in the calcium chloride, and I will now dissolve this. And we'll see if we can see a temperature change. Okay, we can see, according to the thermometer, the temperature is going up. I really can't feel a difference. Although the temperature is going up, it's now at 26 degrees. So it went from 22 degrees Celsius to 26 degrees Celsius. Did you feel the temperature change? No, I didn't feel it. What did you observe? Similar to right here, the solid dissolved. So just because bubbles form does not mean it's going to increase or decrease the temperature. Just because something dissolves does not mean it's going to increase or decrease the temperature. So those aren't characteristics that you can actually predict about a reaction. So let's just kind of summarize in the first experiment with an arrow. The temperature dropped. Second experiment, the temperature went up. Third experiment, it dropped. And the fourth one, it went up. Okay, so now, remember, exo means that it's coming out or exiting. Endo means that heat is going in. If heat's coming out, that means that it is going to feel warmer. If heat is going in, this is like putting your ice inside the water. To melt the ice, it's going to pull in the heat from the water, and it's going to make it, the surrounding environment, cooler. So sodium bicarbonate and acetic acid, this is the vinegar and the baking soda. What evidence do you have? Is this exothermic or is it endothermic? This one is, which one is this one? This is an endothermic reaction. In other words, heat went in from the surrounding environment into the reaction, leaving the surrounding environment cooler. What evidence do you have? The temperature dropped. Going on to the next page, number 2. This is the metal and the hydrochloric acid, exothermic or endothermic. In this one, heat was produced. So this is an exothermic reaction. What evidence do you have? The temperature increased. Okay, the next reaction with the ammonium chloride and the water, the temperature of this dropped. This is going to be an endothermic reaction. The temperature dropped. The last one, calcium chloride, the heat escaped and came out. The temperature increased. Came out, so it's exothermic. So things that are warmer, heat's coming out, exothermic. So calcium chloride is an ice-melting compound on sidewalks and city streets. Explain what's happening. Use the terms of exothermic or endothermic in your explanation. Well, if you put some of this calcium chloride on top of ice, it's going to react with that water, and it's actually going to do what? It's this right here, calcium chloride. The temperature is going to increase. Just by putting that stuff on top of the ice is going to increase the temperature of the ice. And if it increases the temperature of the ice, it's then going to melt the ice even further. So it's exothermic. And because the heat is coming out of the calcium chloride, it's going to melt the ice. So heat comes out to melt that ice. So does the energy go from the surroundings to the chemicals or from the chemicals to the surroundings in an exothermic reaction? So we're talking about the same type of reaction. In this case, it starts from the chemical, such as the calcium chloride, and goes into the surroundings. It comes out. It comes out to the surroundings to increase the temperature. It's the opposite for an endothermic reaction. In this case, the heat comes from the surroundings to go into the reaction. So let's take a look at each of these right here. Classify them as exothermic or endothermic processes, meaning that does it release heat or does it require heat? Melting ice cubes, is this endothermic or exothermic? It is endothermic. Heat goes into the ice, and therefore it melts it. Burning a candle, endothermic or exothermic? Exothermic. Why? You put your hand above a candle, you will feel the warmth coming from the reaction of the wax burning and therefore producing heat in the surroundings. The evaporation of water, does this produce heat or does this require heat? This actually requires heat, the evaporation of water. You need to put heat into it. You need to put energy into the water to cause it to evaporate. So it's going to be endothermic. Baking bread. We have to do what to bread? You have to put it in the oven. Therefore, you have to put heat into it. So bread is not going to produce its own heat. It requires heat. Heat has to go in, so it's going to be endothermic reaction. Splitting a gas molecule apart. Oftentimes when you break a bond, this is going to be exothermic reaction. This is a hard one. The formation of snow in clouds. Well, a lot of people think exothermic must be hot. Endothermic must be cold. Let's take a look at this. If you are going from ice, we're melting ice, we're going from a solid to a liquid. This was what process? This was an endothermic process. And evaporating water, going from liquid to a gas. This was, again, an endothermic process. Well, the reverse process, therefore, is going to be exothermic processes. Exothermic processes. We talk about this in chemistry. Imagine you have liquid wax and it runs onto your skin. It solidifies and produces lots of heat. Heat comes out of that in order to solidify. So these are exothermic processes. So when you're forming snow in clouds, you're actually going from the gaseous phase to the solid phase. And this process is an exothermic process. Even going from gas particles to liquid particles, as we discussed in physics. When your gaseous moisture in the air condenses into a liquid, that's when we form a cloud. And it's exothermic and releases heat to the surroundings. That causes the surrounding air to expand and become less dense. And that less dense air supports the cloud droplet up in the air. So this is exothermic and endothermic reactions.